Alright, just to summarize things, the instance field, this $n, whatever n is set immediately before the call to super, and it's final, by the way. Now, fields from enclosing classes can be used in the call to super, and if the first call of the constructor is to this instead, this $n, whatever n is not set. It's simply passed on to the next constructor in the chain. However, it is still possible to pass fields from the enclosing classes to the call because they can be accessed using the _1 value passed in. Now, if you remember, I was using the convention that _1 is for parameters that I happen to be naming. The compiler just pops off the appropriate one from the stack, but it's that first one passed in. Now, you may not access any instance fields from the class under construction until after the call to super has been run, because by then the instance fields will have been properly initialized. And that's no different to any other class. They all behave like that. You're however guaranteed that there is a fully formed instance of every enclosing class, up as far as the first static class. So you can access fields in any of those classes, instance fields in any of those classes. And of course static fields you can get anyhow. So here's an example to illustrate. Got this class H with a couple of static classes inside, static member classes, and inside of those we're tucking in some ordinary non-static classes. And this is what an instance of HD will look like. It's going to have somewhere in it will be this field that the compiler has constructed, linking you to the enclosing instance of, in this case, HC, which in turn links to an enclosing instance, which will be an instance of HB. And there it stops, of course, because you can have an instance of HB without any instance of H or HA. You can make an HB, simply do new h.ha.hb, and that will give you an instance of HB, and you won't have had to construct an H or an HA. That's why it stops at that point. So there's no link higher up. It stops at the first static one. In this case, it's static. Of course, if those two weren't static, of course it would go all the way up to H. So, but that's obvious. And if we have a look at this, this thing in here, W equals I plus J, then the compiler, of course, will turn that into something else, and it takes the I, and that will be that I there it's after. So it will go this $1 dot this $0 dot I. Get that, and it's pretty similar for J there. So it's fairly straightforward. And of course, if you try and access X or Y just by itself like that, you won't be able to. It will give an error because you need an instance of H to be able to get at X, for example. Or if you have an instance, of course you can do it, but without an instance you can't. So just putting plus X there will give an error. There's some new syntax for new, which deals with this creation of inner classes, especially for that. So let's take a look at that. First of all, as you know, constructors of non-static member classes take an extra hidden parameter, which is a reference to an instance of the immediately enclosing class. Now, to deal with that, we've got this syntactic extension of new. And what it is this: a reference to an instance of a class can be followed by .new, and then followed by a constructor of the immediately enclosed class. And the reference, that's the outer class there, then becomes the hidden parameter that's passed into the enclosed class. So here's an example of that. This class out here has got an inner class in1, and then inside that is a class in2. And if we want to create in2, you can do it all in one go like this. This is public and it's static main here, so we start with in1.in2. That's that type there. But you don't need the out, of course, because we're inside out. And to construct it, we start, because it's this static here, we're going to need an instance of out, so we do new out to start with, and then dot new in1. Right, so that dot new in1 is going to pass an instance of out into the constructor for in1. Okay, so that will make an instance of in1, and then we use that instance of in1 to put dot new after it, and call the in2 constructor, and that ends up making an instance of in2. Of course, you could store this, I suppose, in various stages, and then put it into some local field or other, and then pass that field into the reference, into there, and so on. There's no point doing that. Might as well do it in one go. Right, here's what it looks like if we got statics involved. This is exactly the same, more or less, as what we had in the previous example. But here's a constructor for it. We are making it from outside the class, and we're going to make HD. So first of all, that's the type for that variable. That field H there, the type is h.ha.hb.hc.hd. That's how we describe it. And to make it, first of all, we construct HB, and the type HB is h.ha.hb. So we do new h.ha.hb like that, and that gives us an instance of HB, which we can then put dot new after, followed by HC to construct HC, which we can then put dot new after, followed by HD to construct HD. There you go, we've built HD without constructing H or HA, because as you look at that, h.ha.hb as not being separate classes, but as being the class HB, because that's what it is. It's just happens to have dots in between. Okay.